Hey everybody, it's Mr. Cogshell here. We're going to go ahead and look at this Chapter 1, Lesson 1, your guys' Molecules and Matters worksheet. In this, we're looking at water, so that's going to help us understand what happens at the molecular level with water by kind of playing around with it, okay? So the first part of our procedure here, it says use the dropper to gently squeeze out one drop of water, but try not to let it fall completely out of the dropper. See how far you can let the drop hang off the end of the dropper without the drop falling. Okay, so I have some water here, and all I did to this water is I just put some color dye in it. I thought it would help you guys see a little better. So if I go ahead here and I make as big as a water drop I can, right, and it just barely holds on, but I'm able to make drops of water. And it's not coming out in a stream, but I can just get these big or these decent size of drops of water. Okay? And so then procedure 2, then as it says, place 4 to 5 drops of water together on your wax piece of paper, okay? So you don't want to make your drop too big on your wax piece of paper, else it will kind of, it won't work as well, okay? So you can't have a big glob of water here on your wax paper. So let's go ahead and check this out. So I'm going to, let's see here, 1, 2, 3, 4, 5. Okay, so we have a medium-sized drop there. And if you guys have done this already at home, you notice that this beads up very well, right? If you went ahead and put this on regular paper, it would absorb right into it. Or if you put it on a piece of wood, it would bead up a little bit, but then it would start to run all over the place, okay? So what the wax actually does is the wax does not like water, and the water doesn't like the wax, so the water likes to stay with the water. So then after that, it says gently tilt the wax paper in different directions across the paper so it will move. So if I move it this way, it'll begin to move, and it stays together. The bead stays together. If I move it this way, the bead stays together as it moves, okay? And then it says use the popsicle stick to slowly move your drop of your drop of water around the wax paper. So I can grab this guy, gently move him across my wax paper, and he will move. Oh, and I got them into 2. So that's the second part of number 4. It says try using your popsicle stick to separate your water into 2. So I can do that. I can move this guy over here. He's right here, right? So now I have 2 drops. Or then number 5, procedure 5, says use your popsicle sticks to move the 2 drops near each other and then move 1 drop so that the 2 drops touch. Okay, so I'll start moving this guy towards him, and I'm going to get it real close. And we're going to watch what happens once these 2 guys want to meet. They're really close, and then boom. And they almost snap together, okay? When they get close to each other, they don't form like 2 lumps that are halfway, forming to each other. Is the second they touch, they kind of join, and then they make one bigger bead. And it's not 2 smaller humps, okay? So the question to investigate for this whole activity is, does water hold together well, or does it come apart easily? Okay, and the answer to that is, well, we've seen it come out of a dropper, and it likes to form droplets. When we put it on a wax paper, it likes to bead up, and then when we tilt the wax paper around, it still stays in that bead as it goes around. Okay, so actually water's it's attracted to each other. H2O particles are attracted to other H2O particles.